Oh, hello everyone. Today we are going to solve today's daily lead code problem. Like you can find it here. So let's see what given. It's a medium problem. Problem number 1855. Maximum distance between a pair of values. Okay. You are given two non-increasing zero-index integer arrays nums1 and nums2. A pair of indices I and j where I basically belongs to nums1 and j to nums2 is valid if I less than equal to j and nums1 of I is less equal to nums2 j. Okay. The distance of the pair is j minus I. Return the maximum distance of any valid pair ij. If there are no valid pair, return 0. An array is non-decreasing. Okay. Okay. Okay, so basically the question is straightforward. We are given two array, non-increasing array. We have to find like for any two indices I and j where I belongs to nums1 and j belongs to nums2. We have to find like there are two conditions such that I less than equal to j and nums of I is less equal to nums2 of j. Okay, and we have to maximize this j minus I. Okay, so what can be the idea like? mm, First of all, we can do brute force, but that won't work because the size is 10 to the power 5. Like both of the array can be of 10 to the power 5 size, so that won't work. Uh, One thing we can see that array is non-increasing means we can do binary search also here. So, like for here 55, we will just find like what is the rightmost element which is greater or equal to 55. Like for this here, uh, let's discuss it here. Uh, why it is not visible? Okay, let's do it manually. 55, 35, 42, 55, then 30, then 5, 4, and 2. Okay, and here 120, 10, 10, 5, 100, 20, 10, 10, and 5. So, what is our idea for first of all, like our I is here. So we have to find, uh, we have to find any j in this array such that this j is greater or equal to this I, and we have to maximize this j minus I. So to maximize this j minus I, we have to basically find the rightmost j such that the condition hold. So we have to find the rightmost element which is greater or equal to this I. So for that we can do binary search. What will be our idea? Like we will find the rightmost element which is just greater or equal to 55. Like for this condition, the j will be this, like this 100, because the 100 is only number which is greater or equal to this 55. So for this I, the answer will be 0 because j minus I will be 0. Now for this, for I here, we will still binary search and find this 100. So here the j is less than I, so it won't work. Now for this 5, if we do a binary search, we will get the result here that this is the rightmost element which is greater or equal to this 5. So we will get an answer of 2, because j minus I is 2. Now for 4 also we will get this. The answer will be 1 for this, and for 2 the j will be also here. The answer will be 0. So we have to, for each of these value, we have to find the maximum answer which is 2 for this 5. So that's the simple idea first of all. So what we'll do, we will take the size of both the array, uh, nums1 of size and mm, do we need the size? Okay, let's first initialize answer. Now for int I0, n is basically nums of one dot size, and we will do such binary search like int j. What will be j? J will be like here the array is non-increasing. So we generally do binary search in non-decreasing array. So for do binary search in non-increasing array, we have to pass a custom function which is greater int round nums2 comma current element which is nums1 of I comma greater int. So this greater int is basically a comparator function which will compare the values. And what will the normal upper bound returns basically the first element which is greater than this target. But here it will return the first element which is smaller than the target. So like for this 52, it will return 20 because 20 is the first element which is smaller than this. So if we get this, we know that the good element which is greater or equal to this 55 will be just before this element. So the if we know this j index, we can know that j minus 1 is good. So minus nums1 of dot begin will gives us j, and now we will maximize our answer with j minus I minus 1. Why we are doing this minus 1 here? Because this j index is not good. J is the just first element which is strictly less than this target, but we have to find greater equal to, so we have to decrease the j by 1. And if we return answer, it should work. And we are not checking here like if j is greater or equal to I or not, because if j is less than I, it will produce some negative value which will simply be ignored because the answer is maximizing and answer is initially with 0. So let's run this to see it. Sorry, it should be nums2 dot begin. Let's see in the sample. Yeah, sample got passed, so let's submit this on the main test cases. Yeah, it got accepted. So basically, what is the time complexity here? We are traversing this linearly, so it will be n, and this we are doing binary search here, so it will be log m. So the complexity is n log m, where n is the size of nums1 and m is the size of nums2. So let's think, can we like optimize this further? So as the as basically the array are non-decreasing, if you see very carefully, like for the first one, for the first one, if we do binary search, we are getting this. So let's denote this with 1, means this is the good index for the first one. Now if we do same binary search for the second one, we will get this, because for 30 also the first element which is bigger than 30 is this. Now for 5, if we do binary search again, we will get this. And for the further one, we are getting this. So if you see very carefully, like for any value, like for any element here, if we get a good element here, like say, let's say this is like 60. Let's say this is 60. Then for like 55, we are getting this as good element. So for 30, as this array is also decreasing, so for 30 the answer will be either this or this. Like the answer cannot be before this, because this element is greater than this. So if any value is good for this, that value will be also good for this element, because if this is x and x is greater equal to this, so x will be also greater equal to this because this element is smaller than this. So if you see very carefully, the good element for each indices is basically going also this direction. So we can use two pointer here. Like for first element, if the answer is pointing here, for the next element, the answer may be this or might lie in the right side. So we can use a two pointer. What will our two pointer do? we'll just iterate to the right, denoting the good element. So for that, let's take the size nums1 dot size, and m is basically nums2 dot size, and similarly initialize the answer with this. Now here I0 J0, I and J are two pointers where basically let's remove this, these are of no use. So I and J are two pointer. I is the pointer in the nums1 and J is in nums2. So we will increase the J until J is less than nums2 dot size, and uh, nums2 of J is greater equal to nums1 of I, J plus. So basically what we are doing here, like we are traversing in the first array one by one, and for each value we are getting the rightmost value which is greater equal to this value. Here j is like traversing on the second array, and until this is less than this and this condition hold, it will like go in the right side, and when it will stop either the array all the element has like it is greater than nums2 dot size, or the element is strictly less than nums1, because until this element is greater or equal to this, it will go in the right side. So this j pointer indicates that the current element is strictly less than the element. So for that also we are doing the same thing. We will do j minus I minus 1. This extra minus 1 comes because the j pointer is not denoting the good element. It is denoting just after the good element. So if we run this, this would also pass. Yeah, it passed on the samples. So let's submit this on the test case, main test case, and it got accepted. So what is the time complexity here? So time complexity is basically linear here. So here the time complexity is order of n plus m, where n is the size of the first array and m is the size of the second array. Because if you see carefully, this I is going in every element once, so it is order of n. And this j, if you see overall, like after the whole operation, j is going towards right. So j is traversing the second array only once. So both the pointers are traversing the array only once. So time complexity will be order of n plus m, which is linear, and space complexity is order of 1 because we are not using any space. So that's all for today. Thank you. Let me know in the comment in which method you have solved this, or like what was your thought process when you first see this problem. So thank you.